Okay guys, good morning, good afternoon, good evening, whenever and wherever you get to watch this video. This is Uncle Sam online tutorial and we are back again to learn something very interesting in today's episode of our live YouTube class. Thank you for joining. So for today's class, we're going to be discussing introduction to simultaneous equation. Previously, we've been talking about the laws of indices, and from there we transition to talk about the laws of logarithm. We even solve a couple of questions involving both indices and logarithm. We explored the equation aspect, the linear equation aspect, the simultaneous equation aspect, and equally the quadratic equation aspect of indices, that is the equation in the under indices. And then we also went on to discuss that as well for logarithm. But for today, we're going to be looking into simultaneous equation to break it down in such a way that it will be very easy for you to assimilate. Now, what is the basic idea of simultaneous equation? Why is it important? Why do we need to know about simultaneous equation? Now, the basic idea of simultaneous equation, remember, this simultaneous equation is made up of two words. First, simultaneous. When we talk about simultaneous, something simultaneous means occurring at the same time. Means occurring at the same time. Yes. So that's for the simultaneous aspect of simultaneous equation. And then the equation aspect, in math, when you talk about an equation, you're talking about a true statement. A true statement. And there are characteristics of any given equation. Any given equation must have an equality sign. Any given equation must be made up of two sides. One expression on the left-hand side and the other at the right-hand side. So if you marry these two together, we're talking about that a simultaneous equation is a mathematical expression where you're having two equations that are being solved at the same time. Why two equations? And in this case, this simultaneous equation, the kind of algebraic equation that it's talking about is linear algebraic equation. Linear. So let's get into that. Let's get into that right about now. Now, it's very common that we have an expression like this. Let's say we have x minus 2 is equals to 5. This is a linear equation. Linear equation. And this linear equation is made up of one variable. This variable is also known as the unknown value. Okay? So this is an equation because it has an equality sign. Secondly, it has a left-hand side and a right-hand side. That is it. And then this is a true statement. So we are looking for the value of x. Here, it is only one variable that will satisfy this given expression. One variable that if you substitute here and subtract 2 from, it will give you 5. And then we'll go on to, one of the ways that we'll go on in solving this question is to add 2 to both sides. If we go on to add 2 to both sides, it becomes x minus 2 plus 2 equals to 5 plus 2. And then what we have remaining on the left hand side is that x is equal to 7. So 7 is the value of the variable. Then when we go back to substitute to this given expression and subtract 2 from it, it will be the same thing as what is on the right hand side. Now, but when we now get to simultaneous equation, the beautiful thing and the reason why we pay attention to simultaneous equation is because it's not just having one variable. Yes, this is a linear equation. Yes, linear, because the highest power of the unknown variable x here is 1, because any variable or any number that does not have a power visibly attached to it, by default, the power is 1. Just like this constant 2. This constant 2 have a power of 1, according to the law of indices. So this is why this is called a linear equation. So the simultaneous aspect of linear equation is you having two variables. For instance, you have x minus y is equals to 5. This is still a linear equation. Why is it a linear equation? Because the highest power of the unknown variable here, in this case, the x and y, is still 1. Power of y here is 1. Power of x here is 1. But we cannot go on to solve this equation just like this. Now, why is that not possible? Well, it's possible because there are infinite number of number of values that will satisfy this given expression. There are infinite numbers that we can put in both cases for x and y to what? Substitute, so that it will give us what? 5. something like if I replace this x here to be 2, and sorry, if I replace this x here to be, let's say, 7, and I replace this y here to be, let's say, 2, that will give me 5. That will give me 5. And if I go on to replace here with 10, and then replace here with 5, that is my x becoming 10, my y becoming 5, it's still going to give me 5. So we can go on and on and on and on. There are infinite numbers that we can place for x and y to give us the value that is on the right hand side. So this approach is not what simultaneous equation is talking about. What is now the main goal of simultaneous equation? The main goal of simultaneous equation is, first, it must have two equations. That means a pair of equations, one and another. And that is why it's called simultaneous, because you have to solve the two at once. So let's say we have, let me get an expression for us to carry on the explanation from. Let's say we have an expression 2x plus 3y is equal to 13. And then we'll have 2x plus y is equal to 7. Now, these two are a pair of an equation. And the reason why we call it simultaneous equation is because we are going to be solving the two at once. So what is now the basic logic? Why are we solving the two at once? And why is this so important? Because this is an individual equation, this is another individual equation. Now it turns out that the basic idea of any linear equation gives us like a straight line. If we have to represent any linear equation on a graph, it's going to give us a straight line graph. Now we now have two linear equations, because these two are linear equations. What do you think is going to happen? Well, it turns out that the reason why we are solving these two equations at once, or the end point of solving these two equations at the same time, is to be able to get one value that will satisfy for x and y, one value for the x coordinate and the y coordinate. And in other words, what does this translate to graphically? This translates to a point in the graph where the two lines, maybe it's one coming from here, another coming from here, where they meet, their point of intercept. And at this point of intercept, what do we basically do? We get the x coordinate by tracing the point of intercept for, let's say here is your 2x plus 3y equals to 13. And then this line represents 2x plus y equals to 7. They are both straight line equations. And so what we are solving for in simultaneous equation, the reason why it's so interesting is because we are looking for a point of intersection. Yes, because other than that, if we are to solve this equation, the first one, individually, there are countless numbers or pair of numbers that we can substitute for x and y to give us 13. It's infinite. But the reason why we're getting one value for x and one value for y, when we solve it simultaneously using the different approaches that we have, whether elimination method, which we are going to be looking into today, and also substitution, and also graphical, and also matrix method, and other methods of solving simultaneous equation. The end goal is just to find one number for the x-axis and the y-axis. And that one number graphically just speaks about where the two words, straight line, intercept, where they meet. And so if I get that here is where they meet, what I simply do, what we're looking for, the input of our simultaneous equation is to trace the x, because this horizontal line, this represents your negative x-axis, this represents your positive x-axis, this is your positive y, and here is your negative y. So here you trace to get your what? Your x coordinate. And then you trace here and also get your what? Your y coordinate. So the value of this x and y is the solution to any given quadratic equation. We're looking for the value of x and y. And so that value of x and y is just at a point where the two lines actually meet. That's basically the summary of what simultaneous equation is talking about. So now we're going to get into the different techniques, because we already have a basic idea of what simultaneous equation is all about. The basic idea, why we are getting one value for x. And remember, when you solve, maybe using elimination method, and you get any value for x, what you simply do is, the logic there is, once you're getting any value for x, you take the value of x and substitute in any of the equation. Why are we substituting in any of the equation? Haven't you bothered to ask that question? Why? Why are we substituting in any of the equation? Well, the reason why we are substituting in any of the equation is simply because of what I just explained here. We are looking for the meeting point where the two lines, because each of them is a pair of what straight line equation, where there are two lines what intersect. That is the basic idea. Now let's go on and solve some questions under this simultaneous equation. But before then, let's look at the different techniques. Different techniques of solving simultaneous equation. Different techniques of solving simultaneous equation. Now, there are basically about 3 techniques or more, but the one that is very rampant that we use often is what is known as the elimination method, which we are going to be seeing shortly. We have the elimination method. Secondly, we have the substitution method. Substitution method. And 3, we also have the graphical method, using graph to solve simultaneous equation, because any equation at all can actually be represented on a graph. So graph gives us an avenue to be able to look at it in real time. What is this equation trying to tell us or explain to us? And then fourthly, we also have the matrix method. Yes, there's a matrix method of solving simultaneous equation. So for today, we're going to be focusing mostly on elimination method, because mind you, any question that elimination method can solve, substitution method can equally solve it. And any problem that substitution method can solve, elimination can solve. So we're going to be focusing on elimination method for today. In the next class when we meet, we're going to be discussing the other method. So let's get into it. Hello, Venom! Venom True, thank you so much for joining. I appreciate you, man. Thank you so much, guys. I appreciate you guys being here. So let's go into solving question using the elimination method. As we solve the elimination method, we're going to be explaining it on the way. So solve for x and y in the following equation: 2x plus 3y. This is the example that I wrote up originally, equals to 13, and the 2x plus y equal to 7. Solution. Let's go and solve this together. Now we're going to be using elimination method. Elimination method. I will explain what the elimination method is all about, and trust me, it's going to be interesting and you will never forget it. I'm going to break it down in such a way that you understand what is actually going on, the logic that is being played out here. So the first thing that you do whenever you're solving any given equation, especially when you're solving simultaneous equation, is to arrange the equation, name them. Let the first equation be called your equation 1 and the other one be called your equation 2. This is just about structure. So how do you know your equation 1? The one that is mentioned first. This 2x plus 3y equals to 13. This is our equation 1. And then the other, which is 2x plus y equals to 7. This is our equation 2. Remember, we are using elimination method to solve this given problem. So what is the elimination method all about? Elimination method is quite simple. What are we looking at? When we're trying to solve a simultaneous equation using elimination method, you are trying to eliminate one variable, because remember, simultaneous equation is made up of 2 variables. The 2 variables, each of the pair has what? 2 variables. Okay, so what you are doing when you're using elimination method is you are eliminating one pair of the variable, one of the variable, not one pair, one of the variable completely. You are removing it, and then whatever remains, you use it to find the other variable, find the numerical equivalent of the other variable. I'm going to tell you. And how do you perform this elimination method? You either use a plus sign or a minus sign to eliminate. So here, and you look at the coefficients of the variable. Once the coefficients of the variables are the same, you can apply elimination method. That is why you look at the equation that you're solving under simultaneous equation before you even go ahead, because sometimes the questions are not clearly stated whether you should use any of the method. And so this becomes an added advantage for you. Once you see that one of the variables have the same coefficient for the pair of equation that you're solving, it's easier for you to use just elimination method and solve. So look at it now. We are given this expression. These are equation 1 and these are equation 2. So if I'm to solve using elimination method, I'm looking to check for one of the variables, whether x or y, that has the same word coefficient. So you can see it clearly here that x here, for both the equation 1 and equation 2, it has the same coefficient, which is what? Positive 2, positive 2. So this is positive number. So now the next question is, what sign do I introduce to eliminate? Because I've identified what I want to eliminate, which is the x variable. Why? Because it has the same, both on the first equation and second equation, they have the same coefficient. So what value or what sign do I use to eliminate? I cannot use plus sign, because if I add plus sign here, it's going to be 2x plus 2x, which now does not tend towards what I want it to tend. So I'm going to be using subtraction sign. So if I put subtraction sign, remember what I said, you eliminate using positive or negative sign. So once you've done that, put a line under here, and then you start the process. We're eliminating using what? Negative. So 2x minus 2x, 2x minus this 2x is gone. The same thing as what? 0. Then you put your what? Here, come over here. Plus 3y minus, because you introduce a negative, plus 3y minus plus y. So it's more like saying plus 3y, which is same thing as 3y, minus plus y. These two will go and add on each other, because you cannot have two signs close to each other. They must add. There's an invisible multiplication sign that is what? In between them. So positive times negative is going to give us what? Negative. I'm just trying to break down everything. Subsequently, I don't have to do this, okay? Positive times negative, or negative times positive, is going to give you what? Negative. So this is same as saying 3y minus y, and that will give us what? 2y. Now that we've gotten to this stage. Yes, thank you. Thank you, Shawa. Thank you so much. I appreciate it. Thank you. I love that. So now that we've gotten here, you're going to have plus 2y, because 3y minus y is going to give us 2y. Then it's equals to 13 minus 7 is going to give us c. So you see what we did? By introducing the negative sign, we applied it across the two variables and also the constant values for each of the equation. So now that we've gotten to this extent, what are we simply going to do? 0 plus 2y is same thing as well, 2y. So you have 2y is equals to 6. And what do? We divide both sides by the coefficient of y, because we are looking for y and not 2y. So we divide here by 2, divide here by 2. Y will now be equals to 3. We've gotten our y to be equals to 3. Now what do? When I'm going to say put or substitute y equals to 3 in either of the given equation. So now that we've gotten the value of y, we're asked now to substitute that y, that's the next step, which is equals to 3, to any of the given equation. It will still give us the same value. So I'm going to substitute in equation 1, and right after that, I'm going to substitute in equation 2 to see if it's going to give us the same value for what? For x. We are getting y, we are looking for x. So it becomes, I'm substituting it in equation 1. It now becomes 2x plus 3 multiply y now is 3. So change this to 3 equals to 13. So this becomes 2x plus, if you subtract this, it's going to give us, multiply this, it's going to give us 9 equals to 13. And then what do? You subtract 9 from both sides. It's going to be 2x plus 9 minus 9 equals to 13 minus 9. So this clears out this. It becomes that 2x is equals to 4. So what do you do next? Divide both sides by the coefficient of x. Your x will now be equals to 2. So we've gotten 2. Now I want to do the same for the second what? Equation. See if that is 2 as well. So this is for the second equation. 2x plus substitute y here to be now 3 is equals to what? 7. So what do? You subtract 3 from both sides. 2x plus 3 minus 3 equals to 7 minus 3. This clears this out. You just have that 2x is now equals to 7 minus 3 will give you what? 4. And then if you divide both sides by the coefficient of what? X, implies that your x equals to 2. So you see that for both the first equation and the second equation, when I substituted the value of y to be 3, I ended up getting the same value for my x. And this goes on to explain what I said originally at the beginning of this class, which is that the goal of solving two equations at once when it comes to simultaneous equation is that we are seeking for a point of intersection, because each of the equation originally is a straight line equation. They can be expressed on a graph as a straight line equation. And so now when we're now having two straight line equations and we're asked to solve both at the same time, what you're seeking to do is to find the x coordinate and the y coordinate at the point of them crossing each other. That is the basic idea of what simultaneous equation is all about. And this is the summary of what elimination method is all about. Do you know PW India? No, I don't. Physics. I don't. Okay, so I'm going to solve another question using simultaneous equation. Using elimination method, because that is what we're concentrating on for today's class. I'm going to clean this up now, and then we'll solve another question. Let's go. Let's go. Okay, so I'm going to write out another question. Solve So 3x plus 3y is equals to 18, and 5x plus 3y equals to 28. This is what we are solving for now. So we're still using elimination method for us to get acquainted with it. After now, I'm going to bring another question. That's the third question that we're going to be solving today, where each of the variables for the two equations does not have the same coefficient. And you see what we're going to be doing in that case. So solution. Let's solve this together. We have 3x plus 3y is equal to 18. Now, the first equation that is mentioned here is our equation 1. So I'm going to write it down. 3x plus 3y equals to 18. This is our equation 1. And then the second one, which is 5x plus 3y equals to 28, is our equation 2. So let's get on and solve this using elimination method. First, identify the variable you want to eliminate. And how do you identify it? Make sure that the first equation and second equation, look for a variable that has the same coefficient, that is the number beside it. So if you go to x here, x, which is the first variable here, the coefficients are not the same. We go to y. If you look at y, the coefficients are the same. So we want to eliminate y. And so if we're eliminating y, what sign will we bring? Because you will either eliminate with using a plus sign or a minus sign. And so we're going to be using a minus sign. Why? Because this is positive, positive. If I add another positive here, they will end up summing each other. So I need the negative sign so that they can perform the operation. It can perform the operation that I want it to perform here. So let's eliminate right about now. So if you eliminate, this is first of all going to be active because this negative is acting across board. So what do we do? This is going to be 3x minus 5x. It's going to give us negative 2x. Yes. And then 3y minus y is going to give us what? 0. Yes. So it's gone. But we eliminated the variable y. And then we'll come over here. 18 minus 28 is going to give us minus 10 or negative 10. So we have eliminated the y variable. Let us now go on and simplify the remaining expression. This is now quite easy for us to solve. So this is going to give us minus 3x plus 0 is going to give us minus 2x equals to negative 10. So what do? We are looking for x, not negative 2x. So we clear the coefficients of x by dividing both sides by the coefficients. Divided by negative 2, divided by negative 2. This clears out to have just x remaining on the left hand side. And on the right hand side, we just have what? The negative will clear out. That means it's going to give us a positive number in the end. And then 10 divided by 2 is going to give us what? 5. So we've gotten the x variable. Now over to the y variable. So like we always say, substitute That's the next step. Substitute x equals to 5 in any of the given equation. In any of the given equation. That's the next step to take. So you choose whichever one you want to do. The previous example, I substituted the value of y that we got into both equations to show you that actually you're still going to end up with the same answer. And that is why they boldly made the statement is a very bold statement that you should substitute the value of your x equals to 5 in any of the equation. Because the value you're going to be getting now for your y is still going to be the same. Whether you substitute or choose to substitute in equation 1 or you just choose to substitute in equation 2. So in this case, I want to substitute in equation 2. So anywhere I see x in equation 2, I replace it with 5. So this becomes 5 into 5 plus what? 3y is equals to 28. So this is now going to give us 5 times 5, which is 25 plus 3y equals to 28. What do we do next? We're looking for y. So we clear what is beside y. Now this is positive 25. I'm going to subtract 25 from both sides. So this is something as saying 25 minus 25 plus 3y equals to, let me clear this up and write it a bit. Yeah, thank you, Shama. Thank you. So this is going to give us 25 plus, minus 25. I'm subtracting 25 from both sides. Plus 3y equals to 28 minus 25. So this clears out this is gone. And so what I have remaining on the left hand side is 3y is equals to 28 minus 25 is going to give us 3. And then we'll divide both sides by the coefficient of y. Divided by y, 3 divided by 3, y is equals to 1. So this implies that our x is equals to 5 and what? Y is equals to 1. And like I always say, I want this to be established in your mind because in the course of this topic, we're going to be looking at the graphical aspect. Okay? We're going to be looking at how to plot the graph and show this graphically. But the point I want you to take is this. The solution of any given simultaneous equation for the two variables that we are working on. The solution, what it's trying to tell us is that these 2 points, these are coordinates on the graph. This is the x coordinate and this is y coordinate. And the part that we're solving these two equations as well at once tells us that the values that we're getting is the x and y coordinates at the point of intersection of these two given straight line equation, because each of them are straight line equation. The point that both lines intercept on the graph, their coordinate, their x and y coordinate, it's just like something comes and crosses somebody, crosses the other, the two straight line, and then from here you trace the horizontal component, which is your x coordinate, and then also from here you trace your vertical component, which is your y component. That is the basic idea. Yes, you got your answer, Shwati Kumari. Thank you so much, bro. Thank you. You are good. So this is basically it. Now, we've explored two aspects of this elimination method, where it's either the x, the first example was when the x variable was one that had similar or the same coefficient. And now in this given example, we solved for when y is now one that has the same coefficient. So we're going to be doing another question where neither of the variable have the same coefficient and we have to use elimination method to solve it. So let's go on and see what we're going to do when we have a case like that. That's what we're going to be doing right about now. So let's solve this. So solve the given pair of simultaneous equation. The pair is 4x minus y equals to 7 and x plus 4y equals to 23. So let's go on and solve these simultaneously using elimination method. So first and first, write out the equation. The first equation given is your equation 1. So this is 4x minus y equals to 7. These are equation 1. and then the other one, which is your x plus 4y equals to 23. This is our equation 2. So let's go on and use elimination method to solve this pair of equation. Well, remember that the basic idea of using simultaneous elimination method to solve a given simultaneous equation is that the variable you want to eliminate is more like removing one variable so that you can easily solve for the other. But the criteria is for you to be able to do that. The variable you want to eliminate for the given pair of equation, both their coefficient must be the same. And if you look at these two variables, both for the x and y, the coefficient, if we said let us eliminate the x, the coefficient of the x here is 4. The coefficient of the x here is 1. They are not tallying. Okay, so if we go over here, the coefficient of this y here is -1. The coefficient of this y here is +4. So it's not actually tallying. Here is 1, here is 4. So what can we do? Because we are demanded to use elimination method. What can we do here? What can we actually do here to be able to solve this problem? Aha! Now, this is the basic idea of what an equation is, and I'm going to be, linking something that is very, very important. If I have an equation, let me bring something else into play before I will go on to solve this problem. If I have a given equation, let's say x minus 3 equals to 5 equals to 10. Now, this is an equation now, but turns out on the left hand side there is a fraction. There is a numerator and a denominator. Now, one of the ways that we'll go on to solve this problem is we can say multiply both sides by 5. So we multiply this left hand side by 5. Become 5 times x minus 3 over 5 equals to 10 times 5. Pause. This is where I'm driving to. You see what we did here? Why did we have to do that? Why did we have to do anything on the left hand side and on the right hand side? Why? Because of the idea of an equation. Because this is not just a random statement. I remember saying that at the beginning of this class that an equation is a true statement, is a mathematically true statement. Okay? And so you don't just violate a true statement anyhow. Okay? So what we simply did here was make sure that since the given expression has already been given, that x minus 3 over 5 is equals to 10. Is equals to 10. What we need to do here is anything that we are doing for the left hand side, we must equally do it for the right hand side. That is the only way it is appreciable. Okay? That's the only way that this is acceptable. You cannot just go and do multiply 5 to just the left hand side and leave the right hand side. No. Because this is an equation, this is a true statement. And a true statement, anything you are affecting on the left hand side of the statement must also be affected on the right side of the statement. That's the basic ideology. So now let's go on and solve this. Let's use that here. So what am I simply trying to say here? Now what I'm simply trying to say here is, in this case where the coefficients of the variables are not the same, you have to choose. Make a choice. Which variable do you want to eliminate? Because like you can see, you cannot easily pick because their coefficients are not the same. Which one? Well, I want to eliminate the x variable. Okay, I've picked what I want to eliminate. So the next question is how? Well, how you do that is because the individually they are equation, they are true statement. And what I simply did on the example that I brought in here that I just cleaned now, that's what I'm going to be employing here. What is that? I'm going to be finding a value that I'll be using to multiply both of the equations so that I can get the variable that I want to eliminate to have the same coefficient. That's the basic idea. Yes, that's the basic idea of what I'm trying to do. So I want to get each of them to have the same coefficient. That's what I want to do. So here, I can decide to multiply here by 1 times 1. This equation 1, I can multiply it by 1. And then this equation here, I can multiply it by 2. Sorry, by 4. Yes, I can decide to multiply here by 1 and also multiply here by 4. Yes. So if I do that, 1 multiply everything here is going to give us 4x minus y equals to 7. And then 4 multiply everything here is going to give us what? 4x plus 4 times 4y is going to give us 16y equals to 4 times 23. 23 times 2 is going to give us 46. 46 is going to give us 92. So this is going to give us 92. So you see what I did here? By multiplying each of the given equation by a given number, so that I've decided I want to eliminate x. That is what I want to eliminate. And so I find variable that we use to multiply so that I'll be able to get the same coefficient. I want to use the elimination method. That's the whole point. Okay? Now that I've gotten to this point, I'll now apply my elimination method. And what am I going to use to eliminate? Positive or negative? You guessed, it's going to be negative. Because I cannot possibly add positive here. If I add, they will just be adding together. So 4x minus 4x is gone. It's simple as 0. And then this is simple as saying 0 minus y minus positive 16y. So it's more like saying minus y minus plus 16y. This will go and add on themselves. Positive, negative times positive will give us what? Negative. So this seems like saying minus 9y minus 16y. And that is going to give us minus or negative 17y. That's what we're going to be having. So now that we'll have that, I just brought it out here to explain what is going on. So now that we'll have that, this is something as 0 minus 17y equals to, I will now have 7 minus 92. 7 minus 92. What's it going to give us? 92 minus 7 is going to give us 85, I think. Yes. It's going to give us minus 85. Minus 85. That's what it's going to give us. Now that it has given us minus 85, what are we going to do? We simplify this side. If we simplify here, it's going to give us minus 17y is equals to minus 85. And then what do? We're looking for y, not negative y. So we divide both sides by the coefficient of y, which is negative 17, negative 17. So that your y will now be equals to negative cancel negative. Now, I know that 17, let's take 17 because I don't have it figured out here. 17, let's multiply. Let's say 17 times 5. Let's see what it's going to give us. 5 times 7 is going to give us 35. Take 3. 5 times 1, 5 plus 3 is going to give us what? 85. So if 17 divides 85, it's going to give us 5. So we've gotten our y to be equals to 5. You see the way I did it. Originally, we did not have the coefficients. Each of the variable given, the coefficients were not the same. So this is what we have now. Now y is equals to 5, and we'll do the normal thing. Substitute y is equals to 5 in any of the given equation. Now I forgot to mention something because in maths we need to be very structured. When I multiplied these given individual equation by given a different number, just to be able to boost what I want here, I should have done something very, very interesting or very important. What is that thing? I'm supposed to have labeled that this is now a new equation, this is now my equation 3, and this is now my equation 4. It's very, very important. You need to structure your work. So because you're introducing something, and so you should structure it properly. So now this is what we have here. And so what I'm going to do is, by the way, if you substitute this y to be equal to 5, any of the equation is going to stay 1. Okay? So I want to substitute it in, let's say, equation 1. Substituting in equation 1, which is this. So I'll bring it out, it becomes 4x minus, substitute y to be 5, equals to 7. Okay? And then we add 5 to both sides. 4x minus 5 plus 5 equals to 7 plus 5. And then if you do that, 5 here cancels, so you have 4x is equals to 12. Divide both sides by 4, is that your x is equals to 3. Now if you think this is not correct and this all that, let's try it out in another equation. Let's substitute it in equation 4 and see what that's going to give us. Let's go and do that. Let's substitute this value of our y to be equals to 5 in equation 4. And let's see if it's still going to give us. So remember, we've gotten our x to be 3. Let's see if that's going to give us the same thing as we got here for x. So let's get into that. I'm going to clean here to do that substitution. We're just trying to verify the equation. So substitute in equation 4. Substitute, let me write it, y equals to 5 in equation 4. Let's do that and see what that results. So this is our equation 4. And anywhere we see y, we'll replace it with 5. So this is simply as saying 4x plus 16 multiplied to 5 equals to 92. Yep, that's what I'm going to do. And so if we multiply 16 times 5, 5 times 6 is going to give us 30. Take 0, carry 3. 5 times 1 is 5 plus 3 is what? 80. So we have 80 here. So this is saying 4x plus 80 equals to 92. And once we've done that, we simply go ahead and subtract 80 from both sides. Our goal is to make x a root of the formula. So we're doing everything necessary to make sure that x is alone. Plus 80 minus 80 equals to 92 minus 80. And once we've done that, we're now going to have that 80 will cancel out negative 80, and we're just left with 4x equals to 92 minus 80 is going to give us 12. Are you thinking what I'm thinking? I bet you are. So the same value of x that will go out when we substituted y to be equal to 5 in equation 1, that's the same value that will go out when we substituted it to equation 4, which was what we arrived at because we had to use elimination method. The original equation did not allow us to apply elimination method directly because each of the coefficients of the given variable or known variable, they are not similar. So we have to make it similar by using a standard number to multiply each of the given equation. And once we've done that, we are trying to make one of the variable, the one that we've actually said that this is the one that I want to eliminate. This is one I want to eliminate. So once we've found that, we use a number to multiply the whole equation for each of the pair. Okay? Once we multiply it, we now see that one of the variable for the equation 1 and equation 2 have the same coefficient, and then we use either positive or negative to eliminate it and then solve for the remaining. So you see that this is the basic idea behind elimination method. And the first example that I saw was when the x variable for the given pair of equation, both equation 1 and equation 2, the x variable was the same. You didn't have to do any other thing, you just needed to use your plus or minus sign to eliminate. And the second equation was the y variable that had the same coefficient for the equation 1 and equation 2. And then the third example that I solved here now is when neither of the two equations have the same coefficient for the word variables. And so I now taught you that it's okay when you have those kind of words, expression where the variables are not, the coefficient of the variables are not the same. But that doesn't stop you from using the elimination method because most people get scared. You can actually do what I did, which is using a number to multiply the two equations. To make sure that you get what you are looking for. The question you ask yourself is, what variable do I want to eliminate? Is it the x variable or the y variable? Which one do I want to eliminate? And once you've gotten that, and then you now think of a number that you use to multiply the given expression for the two equations so that you get to the end point that you're looking for. So this is what we're going to be calling it a day for today's class. I hope you enjoyed the class. Please, when are you watching from, guys? Please, can I know where you're watching from? I really like to connect with you all. Where are you watching from? I'm from West Africa, Nigeria, in West Africa. Please, can I know where you guys are connecting from? Can I know in the comment section? Canada! Whoa! Seth, thank you so much for joining, Seth. I really appreciate you, Seth. Thank you. I appreciate you being here, brother. Thank you. I'm good, Seth. I'm good. I'm good, Seth. Thank you so much. Thank you so much for connecting. I really appreciate you. Thank you so much for your support. I appreciate you. Can we, I don't know if it's possible. Like, I really like to connect with you, Seth. I appreciate you. Thank you for the support. Is it possible? Are you on any social media where I can reach out to you? Are you? Are you on any social that I can reach out? Is it possible? Okay. Okay. Thank you. Thank you so much. No problem, no problem. I appreciate. Thank you. Anyways, thank you so much, guys, for joining. I'm going to be live again on Wednesday to continue this discussion. As you can see, we've only talked about the first method, which is the elimination method of solving simultaneous equation. We're going to be continuing with the next method, which is substitution, and then we'll look at the graphical. The graphical is going to be very interesting because we're going to be breaking down the concept of graphing and making it very easy for you to assimilate, because once you learn to use graph to solve problems, it's very interesting because it teaches you visualization, which is very is a technical skill. So I look forward to when we're going to be having the graphical class. Next class is going to be on substitution, solving problem on simultaneous equation using substitution method, and I hope to see you there. So I'm going to be live again on Wednesday this week, same time. Thank you so much for joining. See you guys on Wednesday. Bye bye. Thank you. Yeah, thank you so much, Seth. I appreciate. I understand privacy. No problem, Seth. Thank you so much. I appreciate you. Thank you. All right, guys. See you guys later. Bye.